Hello students, we continue with the lesson on light. First we studied reflection. Now the next topic in light lesson is refraction. Okay. Now what is refraction? Just to give you a small idea of what is refraction, just refer to this YouTube link which I have sent to you. Okay. So kindly watch the video carefully to see the activities given in the textbook. Okay, in the previous activity you must have seen when a pencil is inserted in the glass, is change its path, and after reflection the pencil which is inside the water will look like it is broken and it is moving towards the normal. There is one more activity which is given in the textbook. Here ABCD is a glass prism, glass slab. Glass slab means a block of glass, and a ray of light is passed through the slab, that is EF. Just see, this is incident ray and here is a normal. So after reflection, when you see from the other side, you will see the ray coming out from here, whereas it should take this path EFLP. It is not taking that path, it is taking EFOGH. Okay, and the angle it forms here is angle of refraction. Angle it forms here is angle of incidence. Okay, because here it was air medium and here it is glass medium. Now this is also one of the activities which is given in the textbook. Now let us read what is refraction. That is the laws of refraction of light. Okay, so already I have told you in the previous slide, this is medium 1. Two mediums are present here. One is air. Means what is there here outside? Here it is air and here it is glass. And when a ray of light enters from one medium to another, okay, so if it is, see here it is angle of incidence form, here it is angle of refraction form. So we will just see the laws. First law, the incident ray, refracted ray and the normal to the interface of two transparent mediums at the point of incidence all lie in the same plane. Okay, just like law of reflection, only change in spelling is there. This is same like law of refraction. All the three, incident ray, refracted ray and normal, all lie in the same plane. Second, ratio of sine of angle of incidence to the sine of angle of refraction is a constant. See, you will be studying sine and cos and all in trigonometry. That is sine of angle I. If we take the sine of this angle I upon sine of angle R, this ratio is equal to constant. Okay, for the light of a given color and for the given pair of mediums. So this for particular medium it is constant, and this law is also known as Snell's law of refraction. If I is the angle of incidence and R is the angle of refraction, then sin I upon sin R is equal to constant. Okay, so this constant value is called the refractive index of the second medium with respect to first. Okay, what it is called? Refractive index of second medium with respect to first. Okay, now we will quickly see what is refractive index. Okay, now this all of you are familiar. Medium 1 is air, medium 2 is glass. This is glass slab. The ray of light that travels obliquely from one transparent medium into another. See, air is transparent medium, glass is also a transparent medium. So when this ray of light enters from one transparent medium to the other, it will change its direction in the second medium. See, from here to here when it goes, it will change its direction. Okay, now actually this should go straight like this, but instead of going straight, it is changing its direction and it is moving little towards the normal. N dash is a normal, so it is moving towards the normal. The extent of change in direction that takes place in a given pair of medium is expressed in terms of refractive index. So this means how far it changes. This is compared and it is said as refractive index of a particular medium. Now that particular medium here is glass with respect to air. It turns out that light propagates with different speeds in different mediums. Okay, so if it is different medium, like from air to any liquid, or say water, or from air to any other medium, it will have different refractive index because it enters with a different speed in different mediums. Okay, light travels the fastest in vacuum with the highest speed of 3 into 10 raised to 8 meter per second. Okay, in vacuum it has the highest speed. It travels very fast. In air the speed of light is only marginally less compared to that in vacuum. A little less than what is there in vacuum. It reduces considerably in glass or water. So this reduces, refractive index reduces in glass or water, and the value of refractive index for a given pair of media depends upon the speed of light in two mediums. So it also depends on the speed of light in these two mediums. Okay, now consider a ray of light traveling from medium 1 into 2 as shown in the figure. Just see. Here this is the ray of light AO. It is traveling from one medium. This is air medium, and here it is glass. This is glass slab. That is a block of glass, transparent. Okay. Now let V1 be speed of light in medium 1. So here the speed of light is V1, and here in the glass the speed of light is V2. So refractive index of medium 2 with respect to medium 1 is given by the ratio of speed of light in medium 1 and the speed of light in medium 2. It is usually represented by the symbol N21. Okay, here it is. N21 is speed of light in medium 1. What was its speed? V1. And what is the speed of light in medium 2? V2. So this is speed of light in medium 1 upon speed of light in medium 2. That is V1 upon V2. And how it is written? N21. Same way if we have to compare in the other way, that is the refractive index of medium 1 with respect to medium 2. Okay, now we are going to medium 1. So first we were comparing for medium 2. Now we are comparing for medium 1. So it will be speed of light in medium 2 upon speed of light in medium 1. That is V2 upon V1. Now if medium 1 is vacuum or air, then the refractive index of 2 is considered with respect to vacuum. If it is vacuum or air, it is considered with respect to vacuum. And this is called as absolute refractive index of the medium. Okay, when it is compared with respect to air or vacuum, it is called absolute refractive index, and it is simply represented by N2. Okay, now if C is the speed of light in air and V is speed of light in medium, then refractive index of medium Nm is given by C upon V, that is speed of light in air upon speed of light in medium, that is C upon V. Okay, I told you it is taken to be speed of light in air or vacuum. Okay, the absolute refractive index of a medium is simply called its refractive index. So we don't call it as refractive index with respect to air or vacuum. We simply call it as absolute refractive index, or it is also called as refractive index. Okay, this is a table of absolute refractive index of some materials like air. Just see refractive index of air 1.003, ice is there, water, alcohol, kerosene, and some more examples are there. And the highest refractive index is of diamond, that is 2.4. Okay, note from table 10.3 that an optically denser medium may not possess greater mass density. For example, kerosene having higher refractive index is optically denser than water, although its mass density is less than water. You know that when we put kerosene and water together, okay, kerosene is on top and water is on down, so its density is less with respect to water. But this is when we are comparing with light, it is having higher refractive index that is than water, because it is a denser medium than water. There light refracts more, whereas mass density is less, so it floats on water. Okay, so that density and this denser medium are different terms. These are some question and answers on page 176. A ray of light traveling in air enters obliquely into water. Does the ray bend towards or away from normal? Why? Okay, and it enters from, and traveling in air enters obliquely in water. Okay, so the light bend towards a normal or on entry into water. This is due to the fact that as compared to air, water is optically denser medium. Okay, second question, light enters from air to glass having refractive index 1.50. What is the speed of light in glass? The speed of light in vacuum is 3 into 10 raised to 8 meter per second. You have to calculate this. Now you know speed of light in vacuum, we take it as C is equal to 3 into 10 raised to 8 meter per second. Refractive index, that is absolute refractive index, is C upon V. So speed of light in glass is given, that is 3 into 10 raised to 8 meter per second upon 1.50, that is 2 into 10 raised to 8 meter per second. Question 3, find out from table 10.3. If you refer the previous slide, I have given the table there, it is also there in the textbook. The medium having highest optically density, also find a medium whose lowest optical density. So as per table, diamond was having highest optical density 2.42 and lowest optical densities of air, that is 1.0003. Now fourth one, you are given kerosene, turpentine and water. In which of these does the light travel faster? Use the information given in the table. Now let us see, the refractive index of water is least in all this. Even kerosene having more and turpentine having more. So refractive index of water is least out of three substances. Hence speed of light is maximum in water. So light travels faster in water. The refractive index of diamond is 2.42. So what is the meaning of the statement? If refractive index of diamond is 2.42, it means that the speed of light in diamond is 2.42 times smaller than speed of light in air. Okay, so this is the meaning of this statement. Okay, it means that speed of light in diamond is 2.42 times slower. Okay, so in diamond it travels this many times slower than in air. Okay.